Hello guys, this is the part 2 of our lecture about the properties of solution, which involves a problem solving about these PowerPoint slides. Now again, the PowerPoint's not mine. It is downloaded from the internet, and it is based on the book of chemistry at the Central Science by Theodore Brown, Eugene Lemme, and Bruce E. Burston. So if you want to download the PowerPoint, just kindly click the link below in this YouTube video. Okay, now let's jump to the problem solving, which on the slide number 33. Let's jump to slide number 33, which involves a Henry's law calculation. Okay, now let's start here. Okay, Henry's law states here that calculate the concentration of carbon dioxide in a soft drink that is bottled with the partial pressure of carbon dioxide of 4 atm atmospheric pressure over a liquid at 25 degrees Celsius. The Henry's law constant for carbon dioxide in water at this temperature is 3.1 times 10 raised to negative moles per liter atm, or molarity per atm. Well, it's just a simple calculation. It's just a multiplication of two values because the formula is just here one. Ito lang yung gagamit natin formula. So it is a straightforward calculation. So let's have a SG, the solubility all over Kp. And take note, guys, that the this one here is the partial pressure of the gas in terms of atm, and K is always constant. So what is the one? Henry's law constant here? This one, so that is a 3.1 times 10 raised to negative 2 moles per liter atm. Moles per liter atm, and times the partial pressure of the carbon dioxide, so 4.0 atm. So it's just a cancellation of nodes here, and we have to do some relations, and 3.1 times 2 times 4, and the answer is 0.124 moles per liter of carbon dioxide. So ayan, this is the solubility or molarity of CO2 in water at a partial pressure of 4 atm. So solubility of the gas. Yeah, that's for the answer, and it's just a straightforward calculations, as you can see. Okay, let's now go on to the ways of expressing concentration of solutions. Now let's jump into the problem number 13.4. Okay. Now the 13.4 problem states solution is made by dissolving 13.5 grams of glucose in a 0.100 kilogram of water. What is the mass percentage of solute in the solution? So it's just again a percentage one, straightforward calculation again for this part. And as you can see here, guys, ang formula ang gagamit dito that we will be using is this one, the mass of A, where A is the solute. So the A in this problem is the glucose. Okay, so let's just use one. So percent glucose here. Percent glucose is equals to, I'll just use an acronym for this part, so shortcut. M stands for mass of glucose, so mg. Yan. So hindi ko sinulat yung buong pan. This is just to denote, okay? To denote para mas simplify yung process natin. And then M is just the mass for solution, okay? Where the M of solution, the mass of solution is equals to mass of solute plus the mass of the solvent. Now in this problem, what is the solute? The glucose. So ilan yung mass niya? That is 13.5 gram. What about the solvent? What's the solvent in this problem? The 0.1 kilogram of water. So 0.1 kilogram. So we have to convert this one into grams for us to have a same unit para maging additive yung values. So we have a 1,000 gram here and per 1 kilogram. So it's just a conversion. And as you can see here, ayan. So 1, 2, 3, that is a, ayan, for this one. So 13.5 plus 100 grams of water and glucose. So ayan na. Pupunta na tayo. We have the mass dissolution. Now ito, straightforward ko na natin. 13.5, which is the mass absolute for glucose. And this one here, is 113.5, right? Kasi pag pinag-plus natin yan, it is a 113.5 grams. Ayan, so 113.5 grams to solution. Siyempre, hindi mawala times 100. I'm so sorry for that. Yan. And the answer for this problem is now 13.5 times 113.5 times 100. And the answer is 11.89%. And that is the percentage of glucose of the percent solute or percent glucose in the solution. This one here, this one is for the calculation of parts per million, parts per million. Yan, so we have to, okay, just take a screenshot guys kasi i-cut ko na itong problem na ito. Okay, screenshot taken, I assume. Okay, now let's proceed to this letter B problem, which involves a parts per million calculation. And so here, parts per million. So tatandaan niyo guys that the this scientific notation denotes that the excuse me, that the numerator must be times 10 raised to negative 6 lesser for the denominator. For this example, as you can see here, this one for the problem, it expressed in micro. So when we convert it into grams, right, in terms of 5.4 times 10 raised to negative 6, tama, when it comes to grams. And this one here is the gram here, di ba? Kasi kapag thousands, it's milli. So hindi na ganito yung magiging conversion natin, but rather you will express the ppm, ayan, a direct substitution na agad siya, microgram all over 2.5 grams. And tandaan niyo yung numerator is a millionth decimal places lower compared to the denominator kasi we are expressing in terms of parts per million. Now, kapag parts per billion naman, times 10 raised to negative 9 naman, as stated here. Ayan. Or para mas makwan, this one here, syempre, is times 10 raised to negative 6 higher. Basta importante, yung magiging denominator, yung kanya, yung units niya, must be a millionth lower, but you will not convert it kasi we will express this in terms of this one. So, ang natin dito, ang maging sagot dito is times 2.5 here. Ayan, so that will be the concentration of the zinc ion is 2.16 ppm. Ayan. So, another example is, syempre, di ba, 4 milligram, ang million kanyan is liter. Tama ba? Wait. Milligram is liter, that's 10, that is grams. Wait, I'm just gonna think about it muna. Okay, sorry for that confusing aspect of this calculation. Another approach is I just read the book. Para hindi kayo malito, syempre, ganito ang pwede ninyong gawin is that this one here denotes times 10 raised to negative 6. May purpose pala yan. Okay? As it turns out, kung i-convert natin to for this problem letter B, okay, any of the approach are applicable. Pero ito kasi yung usually ginagamit ng approach. Direct substitution na agad. And you will do you will yield the same answer. Pero dito, tandaan niyo this one is 2.16, tama? Now, let's try to convert it into grams per grams and use this scientific notation times 10 raised to negative 6. Ngayon, okay, as we all know naman that the ppm of zinc, ayan, ppm zinc sulfate, ito pag kinonvert natin to, itong 5.4 microgram here, so magkakaroon ng conversion that 1 times 10 raised to 6 microgram, there is 1 gram. So, magkakaroon ng cancellation for the microgram all over 2.5 grams. So, mangyayari dito, ito na, unit niya ay gram, this one is gram. So magiging kanya is 5.4 times 10 raised to negative 6. I forgot the scientific notation 6 here. Grams here. Tapos 2.5 grams times 10 raised to 6 million. And as it turns out, 5.4 times negative 6 times 2.5, ayan, times 10 raised to 6. Here, ayan. And then times 10 raised to 6, kapag tinimes mo yung results niyan, is ganun din yung lalabas na sagot. 2.16. So ang usually method ko kasi is just nagkaroon tayo ng direct substitution para hindi na tayo magkaroon ng conversion here. But any of the method are preferable, depende sa techniques ninyo. But again, you will yield the same answer. Okay? So next, for the problem here, we will go on to the problem number 13.5. So we have 13.5. And this one here is in terms of molality calculation. 13.3. Okay, so 13.5. This is a molality calculation because calculate the molality of glucose in the solution. Now, in this part, as we all know, that the molality denotes small m, right? And then it is a moles S, where S is solute. Okay, icon ko na lang to. I will denote it in a shortcut way para mas makabilis yung discussion natin. And then it is a kilogram of solvent. Now, as discussed on the previous part of our lecture, that the moles can be expanded into grams per molecular weight. Okay, so grams of solute all over molecular weight of solute times kilogram of solution. Now, if you would notice, paano ba natin makakon yan? So, what is the grams of solute? It is the 4.35 grams. So, mangyayari dito, you will substitute the values here, 4.35 grams. And sir, what is the molecular weight? Ano ba yung solute natin? Glucose. And what is the molecular weight of solute? Ito. So, paano ba natin malalaman yan? And if you're familiar with this naman, just look at this. Di ba? C6 times the atomic weight of the carbon. Di ba? Makikita niyo atomic weights doon sa ating periodic table. Ayan. So, yun lang yun. For the 12 naman, 12 times atomic weight of the hydrogen plus 6 times the atomic weight of the oxygen. Ayan, get the sum and you will yield the molecular weight. But ito, since medyo memorize ko naman na yung mga natin, ang molecular weight ng glucose natin when it is rounded off, of course, that will be 180, I think, but I have to confirm it first. Yeah, it is 180. So it is 180 grams per mole. And then for the kilogram of solution, paano naman natin makuha yan? As you can see here, water ay naka-express siya in terms of ml. And the density of water, the solvent, is 1.00 grams per ml. And syempre, alam naman na natin yung density formula that mass all over volume, ayan, blah, blah, blah. But since in terms of water naman, for every 1 gram of water, there is a 1 ml. So 25 ml can be converted into 25 grams. Ayan. So 25 grams. But we have to express it in kilograms. So therefore, conversion is necessary. Yan. So it is 1,000 grams all over 1 kilogram. Ayan. So, and you will have just a direct calculation for this part. If you wish to do the step-by-step, pwede naman. Pero dito kasi is direct yung ginagawa ko, and I'm so sorry for the technique. I just want to speed up this discussion kasi I am trying to limit the time. And the answer is a 0.966, blah, blah, blah. I-roundin up ko na lang. Sagot dito is 0.97. 0.97 moles per kilogram or 0.97 molality. Yan. So any of these is correct. Ayan, so take a screenshot guys for the okay. Next, calculations. This one here. Now this one here is a mole fraction and molality. Molarity, I think. This is not here. Palitan ko na lang kasi wala tayong molarity example. So I'll use the word molarity instead of molality. Okay? Kasi may molality example na tayo kanina. Okay, ang formula naman yan is also given here. That molarity, ayan, so moles per liter. Mole fraction is the moles of solute. Yan, dito tayo magkawan. Dito natin magagamit yung applications for those both. Okay? I hope you took a screenshot. Okay. Screenshot here, and so we can proceed on our next problem. So an aqueous solution of hydrochloric acid contains 36% hydrochloric acid by mass. Now there are two concentration of solutions that we have to solve, which are the mole fraction and molarity of the hydrochloric acid. So let's do this. So how do we calculate for the mole fraction? Okay, for the mole fraction, it's given in the formula naman that the mole fraction of A, so our A will be the HCl. Okay, saan ba nakita yun? It's here, right? Ayan. So moles of A, so mole fraction of HCl. Ayan, so we have to calculate for the moles of HCl and the total moles. Sir, HCl lang naman yung given. Bakit moles? It's plural. It's in plural form. What are the other? Take note, guys. Aqueous solution. When you say aqueous solution, the solute is dissolved in water. So therefore, the component of our solution is HCl plus water, by which the HCl has a 36%. So therefore, the water is 64%. That makes up, syempre, 100%. Now, this one here, we have to make an assumption that we have a 100 grams of solution, by which we all know it is composed of the HCl, the solute, which is 36 gram, HCl, the solute, and the 64 gram is the water, which is the solvent. Now, from your previous lessons, we have to calculate for their moles, and their moles, the formula moles is just a mass all over molecular weight, tama? So for the mole of HCl, ay guguluhin ko na yung discussion natin, yung board natin. For the mole of HCl, okay, ito ay, ano ba yung mass ng HCl natin? That is 36 grams. What is the molecular weight? So another, again, periodic table, the sum of atomic weight of hydrogen and chlorine. So medyo kabisado ano man na yan. And that will be 36.457 grams per mole. So ma-cancel grams, and we will yield the mole, which has a value of 36 all over 36.457. Meron tayong 0.9874. Rounded off na yun, 0.9874 moles. So yun yung moles na ilalagay natin dito. Yan. Ito pala yon, 0.9874 mole. Pero hindi pa yan yung moles natin kasi meron pa tayong 9874. Plus, I will drop the unit for this part. Lagay ko na yung unit here. Plus, ano naman yung another component? The water, the solvent. So the mole of H2O here is equals to 64 grams all over, at is the molecular weight naman. Ayan, so it is 18 grams per mole. Yung molecular weight, tandaan ninyo, nasa periodic table, SAM. Yan. So the grams cancelled. Yan, the unit gram, yielding a unit mole. So ang value nun, that would be 64 all over 18. And that would be 3.555555. So I will drop ko na lang into for significant figures. So 3.555 mole of water. Ayan, so actually, pwede mo na siyang pagsamin dito para ma-yield mo yung total moles here, but for this one. Ayan, for the mole of H2O. Ayan. So, just a calculation lang naman. So, direct calculation again for the one. Do not do it step by step. Ayan, pagpaplasin ko na tong dalawang to. Ayan, for the sake of shortcut, plus 3.555. And ang sagot natin is 0.2174. The mole fraction of HCl is 0.2174. So, ayan yung sagot. And it is unitless. That is for letter A. But what about letter B? Okay, easy naman na to sa may part natin na to. The molarity, as you all know, di ba? Okay? Tandaan ninyo kapag molarity, ang tinignan doon is the solution. Kapag molality, the solvent. So, dito naman, okay, sige, calculate na natin both for the sake of natin. Dun sa molarity, denotes M, it's just, syempre, di ba? Mass all over molecular weight times liter. So, direct calculation na yan. So, 36 grams times the molecular weight of HCl, that is 36.457, times the liter of solution. Ilan ba yung solution natin, di ba? That is 100 grams. So, dito, wala kasing given na density. And we have to assume again that the density at the ml of the solution is equals to gram. Okay? Assume na natin yan. So, yielding a, kung na natin dito, meron na tayong 100 ml. Kasi nga, grams is equals to ml. So, we have to convert this into liter. Ayan. So, 100 ml, there is 1,000 ml per 1 liter. So, eto dito pala, nakalimutan is grams per mole. Sorry kung ano yun sa. So, maka-cancel yung ml. And again, direct calculation. And ang may yield natin dito is 36 all over 36.457 times 0.1. And ang sagot natin is 9.87 molarity, which is hindi nagtutugma. Yung kasing iba kasi density ng solution natin dito eh. But okay, again, this is just an assumption, okay? There is an actual density of HCl. I'll just calculate it for the sake of the example, okay? The actual molarity of HCl is 12, approximately 12 molars, 12 molarity, okay? But for the sake of example, ayan, in the result for this calculation, that is 9.874 moles per liter. So, tama pala yung nasa book kanina. Hindi ba? This is supposed to be molality. Ayan. And then, sige, kung na natin, sa molality naman tayo, sa molality. Okay, I'll just erase some So, take screenshot guys here. Ayan, I'll just erase a portion of this board. Ayan, so here again, hindi. Ayan, I'll erase this part. Okay, for the molality, so it is actually molality. Yung natin, kaya dapat pala hindi ko na-enable. Okay. Molality is just a moles solute all over kilogram of solvent. So dito, kung naman na dito, as you're all familiar of naman, that the mole, kinalculate na natin siya dito, di ba? It is simplified. Or pwede nyo rin gamitin yung formula sa may molarity kanina na kinuha pa yung mass all over molecular weight. Ayun. Pero ganun din naman yung lalabas sa sagot. Yung trial. Okay? I-prove nyo na lang later on kapag wala kang ginawa. So, ang moles dito is, simplify ko na, is 0.9874. So, yun pala yung purpose ng mole fraction para ma-calculate agad natin yung mole of HCl. And then, the kilogram of solvent. So, ang solvent natin dito, di ba? Kanina sa molarity, we calculate the solution as a whole. But in terms of molality, solvent lang yung ina-calculate natin. So therefore, ang isasultan is 64 grams kasi solvent lang sa molality. Molarity, solution, molality, solvent. But this one here, we have to express this in kilograms. So magkakaroon tayo ng conversion lang dito that every 1,000 grams. There is 1 kilogram. So direct computation again. And our answer is 0.9874 over 0.064. And the answer is 15.42 moles per kilogram. So that is 15.42 moles per kilogram for that. Okay, so take screenshot for this solution so that you can review it later on. Okay, next. I think the last problem for this our discussion is a changing molality using a density of solution. Okay. Calculation of molality. Ba't molarity nakalagay dito? Okay, let's calculate both na lang. The molarity and molality para wala tayong natin. Sige. Ayan. So this is our last problem, and for the part recall, ayan, lecture, that will be a colligative properties. So let's calculate. A solution with a density of 0.876 grams per ml contains 5 grams of toluene and 225 grams of benzene. Calculate the molarity. Okay, sige, dagdagan na natin dito. And molarity of solution. Now, we have to establish yung data. Dito, ano ba yung solute natin? The toluene, 5 grams. So, solute, the 5 grams toluene. The solvent is 225 grams of benzene. Hindi ko na sinulat yung pangalan nila. Ha? That will be yield ang mass ng solution natin. Okay? Dapat may na-assault na mass yan. Ha? So, mass na lang. That would be 230 grams. Yan yung mass ng solution natin. And this one is for the mass of solvent. Ngayon, ikon natin. For the ease, ang gagawin muna natin is to calculate the molality. Sir, bakit po molality? Kasi nga, given na agad yung mass ng solvent. Tama? So, 5 grams all over the molecular weight of toluene agad yan, divided by 0.225 for the kilogram, yun agad yung molality. Ang mas mahirapan tayo sa may molarity, which we will do later on. Okay, punta muna tayo sa molality. Molality is just a mass solute. Okay, ikuan ko na lang M solute na lang all over molecular weight solute times the kilogram solvent. Okay. Now dito, mass of solute, ano ba yon? That is 5.0 grams. And then for the toluene, ano ba yung molecular weight ng toluene natin? That would be rounded up lang to guys. 10.011 times 7 plus 8 times 1.008. C7H8, that would be 92.141 grams per mole. So 92.141 grams per mole. Ayan, so para hindi pa sa nakakagets, okay, that is, di ba? Ang atomic weight ng carbon natin sa periodic table is 12.01 grams per mole times ilan ba yung present sa kanya? So that is 7. Ayan, so we will have a value here. And then yung naman, yung hydrogen naman natin sa periodic table, ang value niya is 1.008 grams per mole times, syempre, ilan ba yung present? 8 all over. Then we have values here, and then pagsamin nyo lang yung dalawa and you will yield this value. Ayan, kunin nyo lang yung sum to get that value. So ito na yung molecular weight natin is 92.141 grams per mole times, ano ba solvent? 225 grams. So 225 grams. Siyempre, kilogram ang hinahanap. So we have to convert it again. 2 grams per 1 kilogram. So direct calculation is also used for here. And that would be 5 grams times 92.141 times 225, 0.225. And the answer is 0.2412. Excuse me, 0.2412. 0.2412 moles per kilogram, or M lang, or 0.241 M. Ayan naman. Okay, next naman. So, we're done with the molarity. Punta naman tayo sa molarity, which is a medyo madali lang na, pero mas fun yung process. May dagdag na process. Okay. Molarity is just a fun. Siyempre, again, mass solute all over the molecular weight of the solute. We all know this, that is toluene. And then dito naman, magkakaiba, the liter of solution. So same values lang din yung sa substitute ninyo, guys, but the liter of the solution is different. So paano ba gagawin natin, guys? Okay. Now, given naman yung density dito, di ba? Isingit ko na lang muna dito sa may part na to. The density, syempre, di ba, density is equals to mass per volume. Hinahanap kasi natin dito is liter of solution. Pero ang given is the mass of the solution is expressed in terms of grams. Tama. Okay, now we have to calculate for the volume, which is, syempre naman, density, that is 0.876. Yung mass is 230 grams. We have to calculate for the volume, which is mass all over density. Tama. Diba? Criss-cross, ano? Criss-cross multiplication and V. Bababa mo yung V. So, derivations lang yan. So, 230 grams. Ayan, for the mass. And then, for the density, that is 0.876 grams per ml. Ayan. So, the grams is cancelled. Ay, ano nangyari? Ayan. So, the grams is cancelled and we will have a value of 230 all over 0.876 grams per ml. That would be 262.557. So the volume of the solution is 262.557 ml. Ito na yung substitute natin ngayon dito. By which, syempre, convert na natin siya sa liter for convenience sa paglagay dun sa equation. So that would be times 1,000 ml. Meron tayong 1 liter, and that would be 0.262,557. So ayan, substitute na natin. We all know that this is 5 grams of toluene all over, ilan yung molecular weight na ulit kanina? 92.141. So 92.141 grams per mole times the, syempre, yung liter, that is 262,557 liter. That would be grams. Ayan, ma-cancel. And we will have a value of 5 times 92.141 times 0.262557. And the molarity, I should say, is 0.2067 moles per liter, or 0.2067 molarity. So either of the two naman is accepted. This is just a shortened form. So ayan, guys, that is the, okay, I think that will be it for the calculations, for the ways of expressing concentration of solutions. Now, in the part 3 of our lecture, we will discuss the colligative properties of the solutions. And syempre, again, we will discuss their properties and calculations. Okay. So this one here, take a screenshot na lang for the calculation. Here, this one. And this one here. Ayan. So pasensya na, guys, kung medyo magulo. But if you will watch the whole video, magigets ninyo yung flow. Okay. So thank you, guys, for listening, and see you in our next lecture.